If a man claimed to be Steve Harvey, how might you know that he's an imposter?
No melanin.
Oh, he's white. Oh, okay. I should have been going. No melanin.
Keep it scientific.
Some of us have rich, dark brown skin. Some of us have pinkish white skin. Most of us are somewhere in between. For the longest time, why this variation exists was a real scientific mystery. In humans, different wavelengths of light are reflected or absorbed by a pigment in the top layer of our skin. That pigment's called melanin. It sits inside what look like tiny grains, the melanosomes, that are produced by cells called melanocytes. Our individual genetic inheritance determines the type of melanin inside our melanosomes. The reddish-yellow pheomelanin is more abundant in lightly pigmented people. More darkly pigmented people have more of the brown-black eumelanin. And the more eumelanin, the darker the skin.
Melanin is a molecule. And the concept of melanin is, it is black in its nature. And we find it in the cosmos, we find it in the heavens, we find it in water, we find it in land, we find it in everything that exists.
Scholars and scientists have been having conferences about melanin, to my awareness, at least since the 1920s. These scientists said that the pineal gland, they refer to the pineal gland as a vestigial organ. That is a calcified gland within the body that served no purpose, as if the creator would create something that you didn't need. And it was only after the Vietnam War, in the late 60s and early 70s, that they began to rewrite their interpretation of the pineal gland. The reason for that was that a large number of African Americans fought and died during the Vietnam War. And whenever a soldier dies, there's an autopsy that's performed before their body is sent back to Dover Air Force Base. And what they discovered, what these physicians discovered, is that when they performed the autopsies, the 75 to 80% of the African-American soldiers had a large functioning pineal gland. The pineal gland is normally about the size of your thumb. So it was not a vestigial organ in 70 to 80% of African-Americans, but it is a calcified organ in 75 to 80% of people with European ancestry. So they began to reevaluate the pineal gland.
So this is a complex molecule. It's found in the brain. It's found in your adrenal glands. It's a powerful free radical scavenger. In other words, it helps the body prevent this oxidation. It's an antioxidant. Melanin may play a much bigger role than just absorbing all this radiation. And when you get it into your body, it actually has a major effect on your immune system. It protects genes and it actually repairs broken DNA. Isn't that wonderful? Something breaks down because you're exposed to chemicals or radiation. Think of the people of Japan right now and who are suffering from huge amounts of radiation. What could we do to help them prevent cancer developing? Well, you need a DNA repairer, and that's what melanin does. It exists in many other tissues, as I mentioned. It's actually a very important molecule in any woman who's having a baby, because the fetus has all this melanin in it.
The sperm of the male and the egg of the woman, they're both layered with melanin, so that when the sperm penetrates the egg, there is a melanin explosion. And that melanin helps to formulate the fetus within that egg. And that fetus is literally coated with the melanin substance. And that melanin substance then goes on to form the brain and the central nervous system. So every human being begins with a melanin explosion.
In steering things in the body, in the whole regulatory system, melanin's role in embryological organization, that's in the baby's organization, and tissue repair and tissue regeneration, may be connected to the major role that it plays to balance the body. That's called homeostasis. Here's a picture of a baby at 35 days of pregnancy, and this is the eye of an embryo. Notice that the eye is pure melanin. That's an amazing picture, isn't it? To see all this melanin is inside, and when the embryo first forms, there is what's called the dark streak. It's all melanin.
It is the dynamic, the primary dynamic in every part of the cell. It's a primary dynamic in the core of the human being as well as to the surface of the human being. Its intelligence is responsible for the forming of the nervous system. Every part of the nervous system has these little black dots all through it, which essentially carry information.
The body is actually a communication system where everything is connected to everything else, and it works through light. It works through light. It's called biophotons. And in this communication system, cells have connections to other cells called integrins, and electrons and light flows between cells. So it's like a supercomputer. In fact, there's somebody even studying whether energy is directly absorbed from the melanin in your skin and transformed into energy in your body. And it's thought to be, by some people, a master molecule that actually steers how the body communicates.
In humans, one of melanin's functions is clearly to protect cells from UV damage. Is there a connection between the intensity of UV radiation and skin color?
Ignition and liftoff.
In the 1980s, concern about the health risk posed by the depletion of UV-blocking atmospheric ozone led NASA to take millions of UV measurements from space. Most striking was the clear gradient between the equator and the poles, which was interrupted only in places where altitude increased UV exposure.
This is actually in the Tibetan Plateau.
And persistent cloud cover decreased it.
Congo Basin, so it's full of humidity and moisture, which is blocking the UV.
George then created a second map using measured skin colors and environmental data. It showed UV intensity does indeed predict skin color. Wherever UV is strong, skin is dark, like it is near the equator or at high altitude. At the poles, the skin of indigenous people is almost always lighter. Of dark skin in humans suggests that under strong UV light, that trait provided a survival advantage. So what is that advantage? It's certainly true, UV damage to skin cell DNA can lead to cancer, and skin cancer can be fatal. For a long time, that seemed the likeliest explanation. There's another side to our relationship with UV light. UV light is not all bad. In fact, the small portion of it known as UVB is critical for the synthesis in our bodies of vitamin D, a process that starts in the skin. Without vitamin D, humans cannot absorb calcium from our diet to build our bones and for a healthy immune system.
The thing is, where once human migrations took many generations, we now move about the planet at the speed of sound. That means increasing numbers of us have pigmentation that's not a good match with where we live.
People with fair skin and red hair, your phenotype is telling you you have a high risk of skin cancer if you're out in the sun. If you're a dark-skinned individual, living, for example, in Scandinavia or in Minnesota, you're not going to have optimal exposure to UV for optimal vitamin D synthesis, and you need to take supplements.